Chapter 28, Part 3, Moon Movements and Eclipses. First, this diagram is showing the moon going around the Earth. You will notice that the moon moves in a counterclockwise fashion. Okay, if I could get my cursor to move. There we go. Also, the Earth rotates in a counterclockwise fashion, both with respect to the sun. Also notice the name of the various phases of the moon, but we'll get to that in a moment. Movements of the moon. The moon spins on its axis. That's rotation. The moon orbits the Earth. Perigee is the point in the orbit when the moon is closest to the Earth, and apogee is the point in the orbit around the Earth when the moon is farthest away from the Earth. At apogee, as shown in the diagram on the left, the moon looks smaller because it's farther away. At perigee, the moon looks larger because it's closer. The moon rises and sets about 50 minutes later each day. The moon also has a slight wobble to its axis, so although only one side of the moon faces Earth, eventually, over a 1-month period of time, we can see about 59% of the moon. And of course, the moon, while orbiting Earth, it also orbits the sun. Just a random comment, what is a tangent? You may have heard of the word tangent in a math class, and that's because it is a math concept. There is one type of tangent that you need to understand: external tangent lines. They cross on the outside between two objects. Notice that the orange line on the top only touches the yellow ball at one point and only touches the blue ball at one point. The 1 point part of this means tangent. The bottom line also crosses or touches the yellow ball at one point and the blue ball at one point. Because the two balls are different sizes, these two tangent lines happen to cross on the outside. They are on the external part of both of the circles. The other type of tangent line that you need to know is an internal tangent line. These tangent lines, will cross in the middle of the two objects. But they are still tangent lines because, I'll use the cursor, this orange line only touches that yellow circle right there and only touches the blue circle right here. But notice it goes in between the two objects, external and internal tangent lines. An eclipse. We have a very important solar eclipse coming up yet this year in the United States. Pay attention in class, and I'm sure we'll discuss this. An eclipse occurs when one planetary body moves through the shadow of another planetary body. Here's the sun, sending all of the light towards the Earth. That creates, because of external tangent lines and internal tangent lines, creates two different types of shadows. The shadow in the middle that is cone-shaped is called umbra, U-M-B-R-A. The outer, less dense portion of the shadow is the penumbra. And here's a photograph of an eclipse. This is in 2017, August 21st. I would love to take everyone down to this. There is going to be a total solar eclipse going right through Missouri and Kentucky. Absolutely amazing. There's a partial solar eclipse. That's what happens when the moon and the sun don't quite line up. Now, is the moon really large enough to cover the sun? No, of course not. It all has to do with how far away the moon is from us as to whether or not we have a total or a partial eclipse. In a solar eclipse, the moon casts the shadow from the sun on Earth. The moon is between the sun and the Earth. People in the path of the umbra, only the umbra, will see a total solar eclipse. People in the path of the penumbra will see a partial solar eclipse. Notice how small the area of the umbra is on the Earth. My cursor is circling that area. A lunar eclipse occurs when the Earth's shadow is cast on the moon. Anyone and everyone on the night side of the moon or the Earth will see the lunar eclipse. Notice how much larger this umbra is. There are three types of lunar eclipses. A total lunar eclipse. The whole moon passes into the umbra. A partial lunar eclipse. Only part of the moon passes into the Earth's umbra. Or a penumbra lunar eclipse, when the moon doesn't even get into the umbra, but is only in the penumbra. This is October 8th, 2014, a lunar eclipse. Notice how the moon diminishes. This is the Earth. This is the moon. What a fantastic little video. These are images from Mercury, where there was an orbiter called Messenger going around Mercury. That's only 66 million miles away that this photograph was taken from, this video, and sent back to Earth. It's amazing what we can do today. The phases of the moon. Moonlight is reflected sunlight. Half of the moon is always illuminated by the sun. However, we can see about 59% of the moon from Earth. The moon orbits around the Earth. Can we always see that half of the moon that is facing the sun? Of course not. There are times when we don't see the moon at night, and times that we see the whole moon. This is what creates our phases. There is a video here that I will make available to you, available through video support on Canvas. This is the end of Chapter 28, Part 3, Moon Movements and Eclipses.